going live, and this is a LeetCode on a Fluke. Today is a sleepy LeetCode on a Fluke. Maybe one problem. Let's see, probably one simple problem for today is the goal. Problem, sum of digits of string after convert. You're given a string. Am I streaming? Yes. Okay. Timer. You're given a string as consisting of lowercase English letters and an integer k. Okay. First convert s into an integer by replacing each letter with its position in the alphabet. Replace a with 1, b with 2, Then transform the integer by replacing it with the sum of all digits. Transform operation k times in total. Then transform the integer by replacing it. Okay, so for example, if and k2 then result would be 8 by the following operation. So we have these, and then we start. So we have a sequence of digits, and we start adding the digits, and we do that 2 times. Okay. So it looks like, in this case, okay, KKK, 99, so 36. So there are several sub-problems here. One of them is going to be a function that what it does, it adds digits. Add digits. And so it should get a number and return the number. Okay, so that's one thing we will need. Do we need anything else? Probably not. So we need to read the letters. So for I is range S, and that gives us SI minus A will give us +1. That will be one. That will give us the position in the alphabet. So that will be a now, and we will need to, so that thing will be a current number. We will want and k is what? K is at least 1. So we want to get the sum of its, and we'll have the sum of its digits. Yeah, right. So sum is 0, probably returning 0. return sum. So we'll do, so we can do the first time. Yeah, so we'll say sum plus, and we'll do the number of add digits. Actually, this should return. I think the problem that the add digits problem is exactly this add. Is there? Is exactly the. I mean, I'm thinking about the naming. I mean, I can call it sum digits. Well, let's do add digits for now. Yeah, let's not try to make it perfect. Let's drop perfectionism. And we put num in it. So that this way we get our first initial sum. And the next time so depending on what k is, because k, if we need to, so this is the first time we'll do the sum of all the elements, of all the digits. Because what we'll do here, once we get a number, let's say it's 26, we get its sum of its digits and we collect it. So we get our first transformation, transformation, not convert. Convert is happening here, and here we do our first transformation. But if k is more than 1, so basically for k, for range of k minus 1, because we already did it, we'll do sum is add digits of sum this time. Yeah, I think like that. And add digits does the following thing. So we need a sum. We will need for x num while x is more than 0, x by 10. So a digit is x modulo 10, okay? So sum is digit. We call it full, yeah. And we return sum. Why is it so? Okay, we declared sum. We have x, which is our number. As long as it's more than 0, what we will do, we'll divide x by 10, which will basically remove its lowest level digit. If it was it will become 12, then it will become 1. Yes, because it will be cutting off this lat. It will be dividing, integer dividing, meaning we will drop the remainder, which is decimal. Okay, I think it should be working now. This should be working. Okay, sum is cannot use non-variable times byte. Okay, so num is, yeah, we need to turn this. Do we? I mean, we can work with bytes, but we need to return an integer. Yeah, so let's do the conversion to an integer before we start. Yay! Yay! I mean, it makes sense. This really makes sense to abstract this part into a separate function. Not only because we use it. I mean, we could use it once here, and we could probably just put that loop into that loop, but it's kind of logical. Because otherwise here we would need I mean, we'll need to create an array of these numbers, okay? And then first do that array and do this the consequent then sums, digit sums. I wonder what the problem is called. Digit sum. Is it called digit sum? Add digit. Add digits. Yeah, that's the problem. Add digits is the problem, but it has like add until it's 0. Until there is result is only 1 digit. In this case, we just needed the k time. I think that's a good warm-up problem. Yeah, good warm-up problem. Yeah, let's about 10 minutes. We took about 10 minutes for this one. Now we do we want to do the medium level problem now? Medium level problem. Medium path sum. Minimum path sum. Given, oh gee, I'm not sharing that one. So I guess that's a good stream. Should we call it a stream? Even and do the medium one tomorrow probably. Yeah, it's 64, problem number 64, minimum path sum. Field with non-negative numbers, find a path from top left to bottom, from top left to bottom right, which minimizes the sum of its path. You can only move either down or right at any point of time. Oh, okay, so what's the minimum sum path. Minimum path sum. Well, it seems to be I'm thinking about breadth first search. But you can only go either down or right. Well, that makes sense, right or down. Down or right. At any point of time. So, I mean, you can go to the adjacent in that direction and until you get to that corner. Yeah. And you probably just want to do all the paths. How many there? There's like 200. 200, how many paths will that be? 200 by 200. There's 200 by 200 is like 4,000. 40,000? Yeah, it's 40,000 squares max. And the difference, I mean, there could be one path, then you might change one. There's one path, and you might. I'm trying to understand how many combinations that is. Can we just try all of them, and just remember and track the minimum? It sounds like 40,000 squares, and then you try to change one. I mean, the two squares will be the same, but the ones in the middle, started in the end will be the same, but the ones in the middle might be combinations of 400 squares, where I don't know, like intuitively I feel it's not going to be too many. It's not going to be like a billion of combinations for some reason. Because, I mean, you can only go to the left or to the bottom or to the right. So that is, and there's 200 the diagonal is 200. So, and if you go to the left or to the right, ouch, 2 to the power of 200. It could be more interesting, this problem, I mean, than it seems. Could be a bit more interesting. Yeah, it's a good one to try tomorrow. So, yeah, we'll pick another warm-up problem for tomorrow, but we have a good medium-level problem for tomorrow already, and maybe one more. So, see you in the next stream. Like and subscribe, and see ya.